There's a
So I'll just begin saying hi, everyone. My name is Aurelio Muraca. I'm the technology program coordinator here at the Danbury Library. I would like to say thank you for joining us this Monday evening, late January, for our next round of Earth in Crisis presentations by the great Dr. Mitch Wagener of WCSU, Western Connecticut State University. Tonight's topic is, what's the entire topic? Economics, the economics
economics
of
of
climate,
climate change.
the economics of climate change. So there you go, Dr. Mitch. Welcome again, and you can start whenever you like.
Right. First, let me plug some talks that we are going to have on campus at Western Connecticut State in the science building, this building that we're looking at right now. In sometime in March and April, the Jane Goodall Center. Jane Goodall has a long-standing relationship with Western Connecticut State University. She's been on campus several times, 5 or 6 times, and I've met her probably 4 or 5 times. And a lovely woman. And she doesn't travel as much anymore, just because she's getting up there. I haven't seen her in several years, but we have a center that is trying to put into practice some of the things that she has talked to us about. And so we're going to have a series of talks, which I'll advertise and I'll pass on to Aurelio in person. It'll consist of one of our faculty members giving a talk teamed up with one of our students, so that students get the chance to speak up about this, being mentored by the professor. It's a good system, and we've been doing it for, this will be the 9th or 10th, something like that, for quite a while.
Right? This one, right? The green one, the yellow one. Yeah.
Okay, so here we are. I'm an ecologist. I'm not an economist, and so the tack I'm going to be taking is I'm going to talk about climate change and the new data which is coming out recently, and give you all some context on that. And I'm also going to be talking about certain economic principles that are important to take into consideration when considering our climate future. So that's where I'm going with all this. All right, come on. Well, one of my favorite pictures, or one of my set of favorite pictures, is a photo taken by the Apollo 8 astronauts in 1968, I believe, around Christmas time. I remember being 9 years old and visiting my grandparents and watching it happen. And some of the pictures that were taken were so spectacular because they were the first photos that we could actually, they were taken from sufficient distance that we could actually see the Earth as a whole and not as just a piece of it. And these are not, I mean, they are photos. They're not a mosaic that's been stitched together from satellites and things like that. And so Bill Anders, the astronaut who was in charge of the cameras, was bright enough to sneak on board. I don't know if he snuck, but take on board a color camera where they had anticipated just using black and white. And the color is pretty amazing. So we have things here. We have things to notice. One is this beautiful dynamic Earth with blue oceans and green and brown land masses and white curly Q clouds forming storms and cyclones and just curlicues. And in the foreground, we see a barren lunar landscape. And the difference between those two is that the Earth has a thick atmosphere and the moon has none at all. Okay. And so the moon is just a different thing entirely. It actually was formed from a collision of the early Earth with a object about the size of Mars. Out popped out popped the moon. All right. It's a beautiful picture too, more than anything else. And yeah, okay. Now, for those of you who haven't come to my talks before, I cover this slide almost every time. It's an important one to draw the contrast between what weather is and what climate is. People might ask, and I've been asked, what do you mean the climate's warming? It's cold outside today. Okay. Well, what that person is remarking on is the weather that occurs right now. And that weather is temperature, humidity, atmospheric pressure, and all that stuff over a short time and over a short space. What you see when you look out the window is the weather. Climate is those same things over a long time scale and over a large area. And so it's a matter of scale, the two, whether climate or weather. And so basically, climate determines what we might reasonably expect from weather tomorrow, in addition to other things going on. So climate's what you expect, weather's what you get. Now, this is new data. This is data for 2023, and each one of these peaks indicates the temperature anomaly, which I'm going to have to explain because that's kind of a unique concept that we don't necessarily see outside of the world of science. An anomaly is a comparison of how things were in a set of areas in one spot from way they were in previous times in the same spots. And so it's a deviation, but it's a deviation where you're comparing to some average value, okay, which is at least 30 years usually. So in the caption down here, the average value, which all of these are being compared to, is the average from 1850 to 1900. So what that means is the average temperature in 2023 was, let's say, 1.55 degrees warmer than the average was from 1850 to 1900. Okay. And the average for this year is put together from data from the same locations, which the average from 1850 to 1900 are put together. And so one spot here back then is on average 1.55 degrees warmer than that same spot is now. Right. So that's how this works. Also, the little peaks are in the form of a statistical uncertainty, which the height of the peak doesn't matter. The height of the peak is not part of the information here. The width of the peak is. The width of the peak depends on the wider the peak, the less certain we are, or more of the spread is of the data that makes up that average. Okay, so as time goes on and they get more of the data worked up to put into our estimate of that year, that peak will narrow as a statistical matter. But, you know, your eyeballs aren't lying. The year of 2023 was significantly warmer than previous years. Okay, part of that is because it's an El Nino. El Ninos are, generally speaking, warmer than the trend. La Ninas are cooler than the trend. So part of it's El Nino, but not all of it. The temperature, and this is also an anomaly because that's how you can accurately present temperature comparisons over periods of time. But this is showing us that put together in a different way, showing each dot as a year rather than as a curve, is showing us that the temperatures are warmer significantly than they have been since we started collecting data, and appear like they could be, time will tell, accelerating. getting warmer faster. This isn't good news. This is not good news, but it's not surprising news either. Now, people often ask me and ask other people who are talking about climate change, how do we know that the warming is from greenhouse gases as we present and not due to changes in the solar activity? Because the sun does warm up, it does cool down, it becomes more active, it becomes less active. The yellow line for the years 1880 through current is showing us the roughly 11-year cycle of solar activity. Okay, it is going up, it is going down, as it does on this 11-year cycle. That we would need much more data to be able to see any kind of trend up, because it hasn't really gone up very much over in terms of solar radiation over this relatively short period of time. Where you see solar increases or decreases in solar radiation is over much larger time periods. Okay. And so Mother Nature's changing of the climate, which she does on a regular basis, are happening over time steps of tens of thousands to millions of years. Whereas the change that we are seeing is happening over the course of decades. And so what tracks along with, correlates with this green turning into blue line here is not solar radiation in this case, but it is, pardon me, the global temperature is the squiggly red line. And what's tracking with it much more closely is the amount of carbon dioxide in the atmosphere. Now, this allows me to point out something else. Now, if we want to measure CO2 in the atmosphere, we can just collect a sample out of the air and run it through a particular gizmo. Usually, they're now they're usually infrared gas analyzers. You shine infrared heat through it and see how much is absorbed. And that's how these things are measured relatively cheaply now. The before about 1958 or something like that, we didn't have a good gizmo like that to collect this data. So how do you know what the CO2 is in the time before we had the equipment to actually measure it? Well, what we do is we go look at ice cores. Ice cores trap bubbles of air when snow is compacted by the masses of snow above it into layers of ice. It leaves little bubbles of air, and we collect cores like this one, and we can determine how old a layer of ice is, because these act just like growth rings on a tree. And you can go back and find out how old or when that any particular layer was in fact snowed onto that glacier, whichever glacier it was, Greenland or Antarctica primarily. Okay, and so there is little bubbles of ice, and we have special techniques for extracting that little bubble of ice and running it through the gizmo I was talking about and getting an idea of what the CO2 was at the year that ice formed. And so that's how we go back and look behind us into the past. And that is the source of data for the green line, whereas the blue line is direct measurements. Now, there is an overlap of this line between 1960 and 1980, and the two of them track exactly. You can see sort of if you were as close to the graph as I am, you would be able to see that there is no significant difference at all between the green and blue line. They are the same. So we're pretty confident that the amount of greenhouse gases in the atmosphere are what are driving the warming over the short time periods when the natural changes take eons. This method was invented by a guy named Keeling, who started collecting this data back in the 50s up on top of Mauna Loa in Hawaii. And he and his successors have been collecting data ever since, and the CO2 is definitely going up. But the other thing you see in this graph, the red squiggle, are seasonal differences. And so CO2 goes up, it goes down because of what the plants are doing. When the northern hemisphere with its great land masses are in the summer, those plants, those trees are photosynthesizing and pulling CO2 down. And in the winter, when they are not active and there's less land mass in the southern hemisphere and fewer trees, it goes back up. All right, so as of just a few days ago, by the way, there's a website, you can look this up, exactly what the concentration of CO2 is. So as of January 15th, just a couple of weeks ago, the concentration of CO2 was 422.36 parts per million. And as of the previous year, it was 419.29. Okay, and it was 280 before the Industrial Revolution. So we've added more than 40% to the CO2 greenhouse gas emissions, but there's other things too that are going in, like methane. That's a different thing. Now, the temperatures we're seeing here can be tracked by geography because of all the satellites we have buzzing around that can take infrared readings off the surface. And you can see those areas that are blue, like the western part of India, were cooler that year than previous years. Anything also in the American West, the Mountain West, a good portion of that was cooler than average, cooler than the 1991 to 2020 baseline. Anything that's in yellow, orange, and red, and that's quite a lot actually, are much warmer than that baseline. And some of those places that are particularly warm are in particularly sensitive areas. Look at Antarctica. Along the, it's hard to know what the northern coast of Antarctica is, but the coast that is between South America and Africa had a very warm year last year. That's an issue because of all the ice that's there that by warming it up, you're increasing some melt, and you're increasing some of the ice to become less stable, less strong. You see other areas like in northern Russia and northern Canada where these are areas of permafrost. And so a warm area there increases more decomposition in the soil of permafrost and allows more CO2 to be emitted by the microbes. So we create these, not we scientists in general, create these maps from data every year. And just a few months after the end of one year, you can see what the map looks like and read it. And I would like to think that the blue would equal the red, but it's not. It's not been a long time since that's been the case. And of course, climate change is a lot more than just warming of the atmosphere. It's also warming of the water. Water that's cold absorbs heat like a sponge. And one of two ways that you can raise sea levels is by warming the water. Warming water makes it expand and take up more space. But if one is doubting that warming is actually happening, and how could you at this point, some people still insist on it. Just look, the ice is melting. If the ice were not melting year after year, if the world were not warming year after year, the ice would not be melting year after year. All right. And in the previous graph where we had arrows showing the general trend, we also had the data. We have data published by Ripple and a bunch of folks in a couple of different publications in bioscience in the last few years. So you can actually see, all right, carbon dioxide, methane, nitrous oxide are moving up rapidly, and as are the surface temperatures and as are the sea ice and all that stuff. Okay, so there's data for all this. It's not a wild guess by any means or anything like that. And this agreement of different sets of data is called consilience, and it's something E.O. Wilson from Harvard coined, and it's the idea that independent, unrelated sources can converge to strong conclusions. And if scientists say that we're quite certain that climate change is real, and we do, it's because we have so many different kinds of data that are collected by different people who may be rivals, and they're all telling us the same thing. So, heat. Now, where does that heat go to? Much of it goes into the ocean. 93% of that extra heat that's been trapped in the atmosphere has gone into the ocean. Okay, we're all getting the economics part. And that heat then melts ice and expands the ocean, causing sea level to rise. And when the ice melts, the surface becomes less reflective. So the North Pole is with the exception of adjacent Greenland, is a ice sheet that grows during the winter and shrinks during the summer. And the more it shrinks in the summer, the more water is exposed and the less reflective the surface becomes. There'll come a time in the life of my grandson, who's now 6, and his sister, who's just, a couple weeks old, when people will be able to paddle a canoe all the way to the North Pole in the summertime. Can't do that now, there's ice, but there will come a time when you can do it, and it won't be long. When that happens, that will actually speed up warming because more bare water is less reflective and will absorb more of the midnight sun. Greenland is the last piece of the last ice age. 16,000 years ago, there was a mile thick layer of ice where I am here in Connecticut in the Danbury area. Much of North America had ice on it, not all of it though. And this is the last piece of that last ice age, and it's melting like a popsicle on a hot sidewalk. This is the more stable, more massive, and colder ice repository, and it's Antarctica, and it's a huge amount of ice. It's high in elevations, perched up on land, like the North Pole ice cap is not. And but they're around the edges. We're starting to see some problems, some vulnerabilities on the, I guess it's the western side of Antarctica. When you're at the North Pole, which way's west? That's what I always ask my students, and no one's ever given me a satisfactory answer. But there are 2 big ice sheets, 2 big glaciers in the western part of Antarctica. One of them is labeled here. It's called the Thwaites Glacier. And just north of it is the Pine Island Glacier. And they are showing signs of deterioration. Now, what that means is that if they deteriorate and chunk into the ocean, there'll be a small amount of sea level rise from just that. But they are corks in the bottle that are holding the ice behind it back. If they were to deteriorate, the ice behind it would more rapidly move toward the ocean, and the process of that ice raising sea level would speed up. Okay, big concern for glaciologists and people who are concerned about sea level rise, because much of the world around the coasts are endangered by it. Now, ice flows downhill, and it does so like water does, only a lot slower. It flows downhill, and when it loses contact with the bedrock below it, it becomes it's no longer an ice sheet, it becomes an ice shelf, because it's a shelf of ice with water below and air above, and then it starts speeding up. It's melted, and the ice shelf gets thinner and thinner until pieces start chunking off and becoming icebergs. Okay, the same thing happens in the Greenland ice sheet or the ice shelves and so on. Now, there are millions, hundreds of millions of people in the world that live very close to sea level and are not in a position where they can easily get up and leave before sea level rises forces them to leave. This particular picture is taken in the Sundarbans in southern Bangladesh. The southern third of Bangladesh is inches from sea level. And it's all in this big swamp formed by the delta, the Ganges, Brahmaputra rivers, and another river, which I can never remember the name of. Okay. And this is in southern Bangladesh and adjacent Western India near Calcutta. And there are 16 million people within a meter of sea level. Where do you go? How do you move 16 million people out? Especially if the final sea level rise is fairly rapid. Where do they go if they do not have the ability to feed their children anymore? Think about that. What would that make you feel if you could not feed your kids? I can't imagine a more helpless, lonely feeling than that would be. It would be right up there with having a very sick child, and it would be a horrible thing. But there are large parts of the world that are vulnerable to that. There are entire countries, such as the Maldives and Kiribati in the Pacific, which are likely to be underwater by the time my grandson grows up. Whole countries underwater. And there are vulnerable places right here in North America, in our country. Southern Louisiana, coastal Louisiana, has already lost a fair bit of land mass, so the shore no longer is exactly like these highway signs depicted to be. And southern Florida is in danger because here we get into some of the economics. In Florida, much, if not most, if not all, of the state revenue comes from real estate taxes. And is that my next slide? And if the sea level rises to the point where those fancy real estate along the coast in Dayton and Broward County and places like that are not insurable for flood insurance, will they be mortgageable? And if a property is not mortgageable, how valuable is it? So states like Florida, who've hitched their wagon, relied on flood insurance for maintenance of the state budget and all that, are going to be in a bad way as well. And as we'll see, people who are underinsured for cyclonic storms, hurricanes. Here's one that's bearing down on the toe of the boot of Louisiana. And as the world warms, the oceans get warmer. As the oceans get warmer, the cyclonic storms get stronger, because that's how hurricanes gain their power, is from hot water that they're moving across. Okay. So small hurricanes, which would be relatively weak, become not so strong and small, and much larger and stronger hurricanes. And any landmass in their way is more in danger, because the sea not only will mess with onshore infrastructure such as oil refineries and oil wells and things like that in Louisiana, which are subject to flooding, but it is also affects those people who have insufficient amounts of flood insurance to handle the cost of rebuilding. There's a concept in economics called a negative externality. And basically what it is an unintended consequence of a industrial or commercial activity that affects other parties without this being reflected in the cost of the goods or services. It's the cost for a third party who did not agree to it. So for instance, if you're in some gathering and someone comes by and lights up a big old cigarette and smokes and blows that smoke in your face, okay, you did not give them permission to come smoke on you, and yet you are suffering the consequences for it. That's a negative externality. It's an accidental cost to you that is a negative. There's positive externalities too. It could be a lucky break, something that happened that caused your fortunes to rise that had nothing to do with you. They're not a concern in this conversation. The negative externalities are. So an example, secondhand smoke or loss of property value when highways are routed through your neighborhood. One of the things that hurricanes do is the force of the wind exerts friction on the surface of the ocean, which then raises a wave higher than the sea level is at that moment, building on whatever the tide's doing and pushes that big wave on shore. Hurricanes typically cause the most damage from storm surge, which is what this is called. Another example of a negative externality is a beach house. Say you have a beach house and it's flattened by a hurricane. The storm surge and wind speed make stronger by climate change. Flood insurance is insufficient to rebuild. The flood reduces the value of your property, but you still owe part of the mortgage. That's a negative externality. The world is full of people who will be the first to suffer when they have not benefited very much from what caused the problems that they're going to suffer from. And then there's places like Miami Beach, Florida, which are high-rise, expensive real estate. This is what I was talking about when I was talking about areas where flood insurance may be prohibitively expensive, so that the mortgage banks, so that property owners can't afford it, and the mortgage banks won't mortgage a uninsured property, and there you go. The geology underneath Miami Beach, Florida, is a limestone that's got all sorts of holes in it. It's like wormhole cities, like Swiss cheese. And what happens is when the sea level rises, it doesn't matter whether you got a sea wall or not. It just comes right up from down below. And Miami Beach government, the city government, is talking about, maybe they've already started it, raising the roads. Now, how many places do you know could raise the roads to deal with sea level rise? Well, these guys are, or at least they're going to try it. There's a whole bunch of other cities, these that are vulnerable. These are those that are found in Asia, some of the most vulnerable cities. And this is a function of not only how bad sea level rise will affect them, but how many people are living in that area to be affected. And so Shanghai, because there's just a lot of people there, would have, a 2-degree raise in temperature would negatively affect almost 12 million people. And there are any number of others. There's a couple of cities there in Bangladesh which are going to, suffer displacements of millions of people. Bangkok probably should be on this list as well. Bangkok, Thailand inland, but it's on a river and sitting at sea level, and the land is subsiding at the same time the sea level's rising, which is not a cheery prospect for them. So our future of mankind, future human civilization will include hundreds of millions of climate refugees. They're already climate refugees. And they're not all from flooding. Some of them are from drying out of agricultural land so that people who are marginal farmers can no longer feed their children and they have to get up and go. We've had that in this country too, you know. Back in the 1930s, there was, well, back in the 1920s, after World War I, there was a particularly moist and positive time for weather conditions that were temporary for the southern plains that caused people to move there and grow and buy land and grow wheat. Also, they were encouraged by the people selling the land. Lots of railroads and people like that were encouraging people to move out and make their fortune. Then in the 30s, the weather pattern shifted back towards really dry conditions, which turns out that that's the long-term normal. They're long-term. When a scientist says that something is normal, they mean average, a long-term average. And so the dry conditions of the Dust Bowl were the long-term average of that area, in contrast with the decade before, which was relatively wet. And actually, people were successfully growing wheat. But as it dried out, the wheat failed, and the roots of the wheat and roots of other plants that didn't do well decomposed, and big gusts of wind came in and blew up the soil, and off it went. And you have the Dust Bowl. And certainly a lot of Americans were affected by this, including two of my grandfather's uncles, Uncle Thurbert and Uncle Cecil. Really, that was their names. And I knew Cecil reasonably well when I was a kid. He and Thurbert, their brother, did move to California, and I don't know under what circumstances. I wish I had asked them at the time, but it didn't occur to me when I was 10 years old. And they were able to make it, and they were able to come back and visit, and they were visiting my grandfather. But we know, we read the books, we've seen the movies, and this is an accurate depiction of how it was for millions of people who thought that California was the Garden of Eden, and they went out west and they were met at the border. Here, this was Americans met at a American state border and told that there isn't anything for you here, or led in to work and not treated well. There are places all over the world that are showing an increase in drying. Much of Africa is drier than it used to be. There are other areas that are wetter than they used to be, because more heat makes more evaporation, which puts more water in the air, which causes precipitation in some areas to go up. Now, so climate change to me is a moral issue. The people who are least responsible for causing it are the most vulnerable to it on a global scale, including many of the people who are looking to make a better life in this country, coming from other countries, are leaving behind conditions which were made worse by climate change. Our country itself, over the last 30 years, much of it's actually gotten wetter, but some areas have gotten drier. And so the extreme of more precipitation is shown here in this map. As compared to well, the comparison of the precipitation between 1901 and 2016. Yeah, that's what we're seeing here. Now, another thing that we're seeing, and partly because of changes in the jet stream that are a function of warming of the high latitude, the Arctic areas, but we're starting to see things called heat domes. Heat domes are a high pressure system that acts like a convection oven and keeps getting hotter and hotter and hotter as it sits in one location. And it stays there until some other thing, usually another high pressure, knocks it out of the way. Another side of climate change is in those areas that are getting warmer and drier, we're seeing more fires. This last year was a good example of that. I was in a restaurant giving a talk to the Reading League of Women's Voters on climate change, just this topic. And when I went in, it was a bright, sunny, clear day. And when I came out, we had all that smoke that was blowing down from Canada, and the changes just happened over the course of an hour. And so those areas where the particular climate, which is conducive to fires, becomes more, where in areas where it becomes more of that climate, more like that climate, we're going to have more fires. Connecticut, not as much, but we're going to get the smoke from those in Canada and maybe some other parts of North America. Down in the tropics, in the Amazon and some areas like that, we have other fires that are causing loss of forest, and some of that is from weather conditions, but a lot of it is humans going in to clear land so that they can raise cattle and grow soybeans for foreign markets. Fire climate is associated with an area that is prone to periodic wildfires, is an area that has dry weather, that it follows after a time when there was enough rain for the plants to grow up, a heat, and the presence of dry lightning that's not associated with rain. And if an area takes on more of these characteristics, it will be more prone to wildfires. Hey, they happened on Maui last year, catastrophic ones. So there are a lot of places where one might not expect there to be wildfires, which we can expect them going forward. These areas are showing increases in the number of annual fire weather days from 1973 to 2020. Areas where those conditions in that previous slide are becoming more common. That's my wife coming in from work behind me. Now, there are things that we can do. We are not helpless. To a large extent, we caused this, and by God, we can fix it. But we have to be willing to, and we have to stand up, perhaps to some naysayers who say that we can't or shouldn't. I still have, occasionally, you'll have people come up to me and say, well, you know, climate change, I think, is real, but there's just no way we can possibly ever do without fossil fuels. And I talk to them a little while and find out that they're retired from the oil industry, and so perhaps that they're concerned about their stock futures. Anyway, there are things we can do, and there are things we can do that are small scale individual things. You can vote your values. When there are choice of candidates, find out which one fits your values the best and vote that one. That's my dog whimpering in the background. You can speak up with your voice, your time, your money. Let your representatives know how you feel about things. You can buy from and spend your money with companies that have good environmental records and so on. These are things that we can do as individuals. We can be active in state and local affairs. We can, as individuals, burn less carbon. Okay, we can electrify our lives, our homes, and so on. Purchase renewable electricity, which we can do from EverSource or wherever you get your energy. At least we can in Connecticut. I can't speak for the whole world. And we can buy at and add will and willingly pay a little extra for renewable electricity. We can eat less meat. Okay, that probably all make us all a bit healthier as well. We can be compassionate. We can teach our children to be compassionate. We can demand it from our elected officials and policies they enact. We can learn and teach our children about the environmental justice, the negative externalities that some people suffer, and how we can do a better job of being good citizens ourselves and being good neighbors. We as a collective can educate our children about climate change. That is a statute for public schools in Connecticut. We can support climate education in our schools. I was visiting a second grade class just a few weeks ago talking about earth science to get them ready with the concepts that they can understand climate change and when they are a little older. We can make sure that all the oil wells are capped, the ones after they are done pumping, because otherwise they'll continue to spew greenhouse gases in the form of methane into the atmosphere. We can eliminate subsidies of fossil fuel companies. Honestly, if all the subsidies were take off both fossil fuel companies and renewable energy companies, renewable energy would still win. Even without subsidies, it's in long term is going to be cheaper. We can shift from, as a civilization, from refrigerants that are horribly strong greenhouse gases to those that aren't. We can make education available to all girls. Now, one of the scarier concepts, economic concepts, and this is one that was first spoken of publicly by a Canadian economist who, at the time, I think he was either the governor of the National Bank of Canada or the National Bank of the UK. I'm not sure which. And he dared utter in public, as one of the world's great economists, that in order to limit temperature increase to 2 degrees Celsius, which is pretty vital, 80% of the existing fossil fuels must remain in the ground, unburned, stranded assets. So think about all those countries that rely on fossil fuels for their not only finances, but their influence in the world. If you were to tell them that they had to take and ignore 80% of the fossil fuels that they have on their books, they will not be very happy. They were not very happy with this economist when he spoke up. There were a bunch of people who started screaming at him. And imagine what it would be like likewise if you were to say to fossil fuel companies in this country, all that gas and oil that you're digging up, walk away from 80% of it. This is going to be a hard fight, and it's going to cause some hard decisions that are going to not be universally loved. But climate change is real. It's us. Experts really do agree. It's bad, but there's hope. There's hope with a contingency. It's hope given that we are willing to do something about it and sacrifice for our grandchildren. We have to participate in this hope. We have to put our heads together We have to find workable solutions. We have to put them into play and have more of a concern for the future of our grandkids than we do of our particular future. There's a light in the end of every tunnel, but we will never get out of the darkness without collective will to change. And the change is how we take responsibility for our actions and things that we see with our own eyes are happening, how we make decisions, how we prioritize, and how we see the world. If we wait for future technologies to save us from having to make inconvenient changes, and we wait for others to do the heavy lifting sometime in the future because it's inconvenient or would force us to make changes in our lifestyles, the planet for our children will not be a good place. Now, it is tempting, and you hear this sometimes when you do what I do, people saying it would be too expensive to fix the problem because it would mean that there won't be money for future generations, or there won't be facilities, or the economy will go broke if we fix the problem. To which I answer, and other people do too. If you want to see how much it costs to fix something, just imagine what happens if you don't fix it. The cost of cleaning up after it happens is going to be far higher than keeping it from happening at all. It's sort of like the old Popeye cartoon where that character would say, I'd happily pay tomorrow for a hamburger today. We are making decisions for our own best interests without sufficient consideration for the conditions of our grandchildren, including the cost of human lives from a world that is significantly degraded from it is now, including what we owe future generations. Another concept in economics is something called the discount rate, where we will assume that the value of something in the hand right now is higher than it is in the future. We have to get away from that kind of thinking. What do we owe future generations? How much are we discounting the value of our grandchildren's future? And at that, I will be happy to answer questions. As always, if I don't know the answer, I'll honestly tell you I don't know the answer, and then I'll try to find out the answer.
Thank you, Dr. Wagener. If anyone has a question, just feel free to put it into the chat. I will read it off to Dr. Wagener, and he'll try to answer it the best he can. I think this was a great presentation. I thought it was really well putting like, the economics of what we stand to lose. Because that's what it is sometimes, even just, for governments, putting a dollar value on it really does, bringing stark reality.
Well, and you think you have to look at caring for the future generations as an extension of the golden rule. We are all taught in parents or Sunday school or somebody that we should do unto others, treat people the way we want to be treated. But we have to be more expansive at that. We have to extend that to people we've not met in countries we've not visited. We need to extend that to future generations. And if we do that, if we look at our care for the earth and the future generations and doing right by people on other sides of the world, then we have the basis for an ethic which will save human civilization.
I agree.
So I believe.
Any questions? from the audience this evening? If not, we could just, oh, here we go. From Chris, let's terraform the Earth back to a cooler, greener Earth.
Well, that is something that we will have to do to some degree. It's called geoengineering, and it's fraught in some ways. There are some considerations that we're going to have to think it through. We are going to have to engineer the hell out of everything, and to get the ability to actually do that in a way that we're confident that we're not making it worse. There are ideas afoot, and you sometimes see them in a science, in a genre of science fiction called climate fiction, sci-fi, of putting a bunch of particles in the air to reflect sunlight, and maybe we'll find ourselves needing to do that, but there's danger. Francine Miller has a question.
Francine, can you type it into the chat?
No, I can't. Actually, I can't.
Okay.
Please ask.
All right, thank you. I heard something very frightening to me. I don't think it's well thought out, and you may have just touched on it. And it is putting something that I'm saying stop the reflection. It's not quite the right word. Stop the reflections of the sun. Restrict the reflections on the sun to cool the earth. And I'm thinking, what about our farmland and our grazing land that requires sun all the time?
Yeah.
And so I was listening to scientists talk about it, and to me, it's not something that they have. Maybe I'm wrong, but that they haven't thought of the repercussions.
Well, and that's kind of what I was talking about. And if you put something in the upper atmosphere to reflect away sunlight, you have unintended consequences to that. And we do need to think all that through and do quite a bit of research. And we do have some time to do that, but we need to, it's a fraught, it's an emotionally fraught, and it's a dangerous thing. And I suspect that we should not do that unless we are in deadly earnest.
We have another question. Thank you, Francine, for that. That was a very good question. I've heard of, this is from Maureen, I've heard of machines developed that can help remove CO2. What do you know about them?
Well, the best machine for doing that is one that, also produces goods for us in our forests. And so one thing we can do is we can make sure that we conserve and enhance our forest as well as we can, because then you get the byproduct of healthier wildlife, and you get forest products which you can use for other purposes, building materials and things like that. There are machines, at least on the lab bench, that can absorb CO2 out of the atmosphere. Scaling up is going to be an issue. That means taking something that you can do on a laboratory bench and making it big enough where it make a difference. Also, all of those are going to require energy of some sort. And so it's a matter of building the thing so that the savings are worth more than the costs.
Thank you for that question. Next question is, when you say eat less meat, are you talking about beef or all meats?
Oh, I just meant it as a general principle that there are some forms of animal protein that are beef probably is more damaging to the environment than chickens, for instance. I'm not pushing that. I think it is probably something that we are going to have to do eventually, and it has the extra benefit of being being more healthy for us. But there are people who think very strongly that we should all go vegan, and I can't argue with them. I really can't.
Thank you for that question. Thank you for answering that. The question from Harriet, is there a way to help now the countries most at risk of going underwater?
some of it all depends on how bad the conditions are. In Indonesia, which is an island nation, it's got lots of islands, and the capital city, Jakarta, is on the coast of Java, and it is threatened by flooding. And to their credit, the Indonesian government realizes that, and they're planning on moving the capital, building a new city on the island of Borneo, which is higher elevation, and moving their governing government to that area. Okay, there will be things like that must be done, but there has to be a will. Bangkok. I lived in Thailand for a year, and in high school I was an exchange student, and it was a transformative experience for a 17-year-old, I'll tell you. And Thailand has this big city that's an old ancient city full of old beautiful temples and spectacular temples and palaces. That's what I was trying to say. It's beautiful palaces and spectacular temples, or whatever you want to say that. And they are so important to Thai culture that the government is loath to start moving people out of Bangkok, because it would be bad for the tourist business, of which Thailand relies a great deal. And so what do? So are you going to wait until it's an emergency and you have to move those 10 million people in a big rush with lots of people falling through the cracks? Or do you do it gradually and humanely? We need to think about the humanity of this. It's not just bucks. I mean, economics and finances are important, of course, because that's how the world runs, but we need to think about the humanity of this. I don't know. Did I answer the question? Kind of went off on that.
So. Well, final question, and it doesn't help us that one president undoes the progress of a previous presidents, and it keeps happening.
Well, I can only say for myself that one of the criteria I use for voting for elected officials is how they stand on environmental issues, and particularly climate change. I agree. It is seesawing back and forth from sublime to ridiculous is not helping. But this is a democracy, and we need to wisely choose the people who exercise that power.
Exactly. Thank you so much, Dr. Wagener, for this evening's presentation. As you all know, this is recorded, and it probably will be available. I'll send you all a link, possibly tomorrow. So that's the fastest I can do it.